Well, welcome back. This is going to be lesson 3 of the chapter that is chapter 3 on projectiles. And so let's move on here. This is physics 11. We're working from page 4 from the work booklet. And if you don't have it, there's a link down below that you can go grab it, or you can grab it from the Moodle. So let's just continue on with questions 4, 5, 6, and 7 as promised. Let's get these done. So, a skier leaves the end of a ramp with a velocity of 25 meters per second east and lands 70 meters from the base of the ramp. How high is the end of the ramp from the ground? Now the horizontal end, a horizontal end, so, and there's your skier here. And he's off this horizontal ramp and he's going at 25 meters per second. He's flying. And he lands 70 meters away. Okay, hopefully it's going downhill at this time and he's not going to hurt himself. But let's see how that works. How high is that ramp? So we're asked, what is that height? That's the vertical height. So this is what we have to figure out. We know this is 9.8 and it's down. That's meters per second squared. The initial velocity is 0 because this is a horizontal end. He's launching off at 25. And that's it. We don't know how fast he hits. He's going down when he hits there. And we don't know the time of the flight. So we can't solve this because we only have 2 of them. So we have to go back to here. What else do we know? He lands 70 meters away. And he's traveling at 25 meters per second. Yes, he's traveling east, and I'm sure this is going to be an east here as well. And the time, well, we're going to use the formula that velocity is displacement over time. So time is going to be distance, displacement over velocity, and that'll be 70 over 25. Pulling up our calculator because, hey, can't always trust ourselves. To get 2.8, 70 divided by 25 is 2.8. So he's in the air for 2.8 seconds. So I'll put it down in here. This is calculated as 2.8 seconds. So we now copy that over here, 2.8 seconds. We can get D now. We could also find the F, but that's not what we're asked for. We're finding D. And D we'll use is VIT plus 1/2 AT squared. This term here is 0 because VI is 0. So it's going to be 1/2 9.8 times 2.8 squared. So we go 0.5 times 9.8 times 2.8 squared. And that's going to give us our range, or distance horizontally, 38.416. Dun, da, da, da. Let's move on to question 5. Pause it if you want to have time to copy it down. 3, 2, 1, here we go. An astronaut stands on the edge of a lunar crater and throws a half-eaten Twinkie horizontally with a velocity of 5 meters per second. The floor of the crater is 100 meters below the astronaut. What horizontal distance will the Twinkie travel before hitting the floor of the crater? And the acceleration due to gravity on the moon is 1/6 that of Earth. Oh, this is a challenging question. There's a lot more here. So there's a crater, and the astronaut standing there and throws this black Twinkie, and we want to know what is the horizontal distance that it travels, that horizontal distance. That is what we're trying to figure out. So he does throw it at 5 horizontally. Again, we're emphasizing that it is horizontal, so 5 meters per second. The acceleration is 1/6 of 9.8. The initial speed is 0. Landing on the floor of the crater 100 meters below. So it's 100 meters. Okay. So the time is what we want to figure out and bring it over to there. And the time, like done before, is going to be the square root of 2d over a. I can do that because the vi here is 0. So we can do that. So this will be 2 times 100 divided by 1/6 of 9.8. So if you want to get that number, 9.8 divided by 6, this number is actually 1.633. Okay, so we just plug it into the calculator. That'll be 2 times 100 divided by 1/6 of 9.8. And then we have to square root it. Whoops. So I'll still square root that. So it'll take 11.05 seconds. 11.06 seconds, sorry. Okay, you want to see it, you do it in one step. Square root of 2 times 100 divided by, and let's use that number I calculated, 1.633. Okay, since I only did 4 sig figs here, it's only accurate to the 4. So that's the time. Now that we have the time of 11.06 seconds, the distance is going to be velocity times time, 5 times that 11.06. So 5 times that number is 55.33 meters. Okay, let's pause it and I'll go back and listen again. I'm going to move to number 6. A movie stunt driver on a motorcycle speeds off horizontally a 50-meter high cliff. How fast in kilometers per hour must the motorcycle leave the cliff top if it is to land on the ground below at a distance of 90 meters from the base of the cliff? So it's 50 meters high, and he needs to land out at 90 meters from the base. Okay, so we have the horizontal distance is 90, and it is 50 meters down. The acceleration is 9.8 meters per second squared down. And the initial velocity is 0 because it says horizontal. So it is 0. So we have these three quantities again. We can get the time is equal to the square root of 2d over a. And that's going to equal 2 times 50 divided by 9.8. So let's figure that out. The square root of 2 times 50 divided by 9.8. Again, we can only use this little shortcut formula as long as VI is 0. And it is. 3.194 seconds. 3.194 seconds. So the velocity, or speed, is distance over time. And that's going to be 90 divided by this time. So we will divide this. Whoops, no. We'll take, let's just back off here. We will take 90 divided by that number. And that'll give us the speed in 28.17 meters per second. But it says to convert it to kilometers per hour, somewhere around here in kilometers per hour. So we will multiply that by the 3.6 that we've been trained to do, and it's 101.42843 kilometers per hour is what they're asking for. Again, the conversion, in case you didn't get it or you weren't in my class at that moment, we'll do the 28.17 meters per second. We want to convert that, so we want to get rid of the seconds. We want to put hours down below because it's kilometers per hour, hours in the denominator. So there's 3,600 seconds in 1 hour. So this bracket equals 1, that's fine, that's good. And then we want to get rid of the meters, and we want kilometers. So 1 kilometer is 1,000 meters. So the seconds will cancel out with the seconds, the meters will cancel out with the meters. The units that we end up with are hours in the denominator and kilometers in the numerator, kilometers per hour. So then we have to just take this 28.17, multiply it by 3,600, and divide it by 1,000. Well, this is the same as 3.6. So that's why we multiplied by 3.6. Okay, so I took the answer of 28.17 and multiplied by 3.16, and we get it in kilometers per hour. There's the shortcut, or the long cut. So let's just work on question number 7 now. A rock thrown horizontally from the top of a cliff 98 meters high with a horizontal speed of 27. For what interval of time is the rock in the air? So it's a cliff. It's 98 meters high. And it's thrown at a speed of 27. So the horizontal speed is 27. The vertical speed is 0. The distance down it's going to go is 100 meters. 98 meters, sorry, and it's 9.8 meters per second. Second squared. Whoops, let's just undo those things. Meters per second squared down. So the time is going to equal the square root of 2d over a, because VI is 0, because it's horizontal. Because of that, we can use that. And we get 2 times 98 divided by 9.8, all square rooted. Square root of 2 times 98 divided by 9.8, and that'll be 4 seconds. Well, 4.472 seconds. And D here is going to be velocity times time, and V is 27 and the time is 4.472. So we multiply this by 27 and we get 120.75 meters. Okay, so what interval of the time is in the air for? Well, the time was 4.472 seconds. How far from the base? It landed 120.75 meters. And what velocity, what vertical velocity does the rock hit with? So we're asked to find that. Well, let's find it. There's going to be 3 different formulas that we can use. I will just use VF equals VI plus AT, because VI is 0, VF is going to be AT 9.8 times this time of 4.472, and we get 9.8 times that number, and we get 43.83 meters per second, and it's down. Make sure you put the direction there because it's asking for the vertical velocity. A direction is required. It says velocity. So when it finally does hit, when it hits right down there, it's still traveling this way at 27, but it's also traveling down at 43. It's traveling both of those speeds at the same time. There we go. Remember, subscribe, click the like, add a comment. Just kidding. Anyhow, thank you very much, physics fans, and what should we do? Well, let's assign some homework. Just if we scroll to the next page, or turn to the next page, page 6, there's questions 8, 9, 10, and 11. 4 more questions, and you'll notice that the answers are out there. The answers for the ones we just finished are there. Okay, although 7C doesn't seem to have the direction, so it's not the correct answer. It needs a direction, guys. I'll have to fix that for next year. So take a look at that, and number 11 pushes the challenge that it's asking for. What is the total velocity of impact? So it's asking for the total velocity, not just the horizontal, not just the vertical final velocity, but combining them together. That's interesting. So move ahead, keep going, and let's have some physics fun. Okay, thanks physics fans. See you next time. Get those done.